Good afternoon, ladies and gentlemen. This is Mrs. Ford, and we are going to discuss today multiplication and division of rational numbers. First thing that I want to talk about is when you're problem solving, you need to know the difference between multiplication and division in a word problem. So, first let's go ahead and set up our Venn diagram. We're going to say multiplication is on the left, and division is on the right. And I'm going to use a different color so we can separate this out. Never mind. We will use black. Alright, so taking a look at what we've got going on here, you should remember from what we talked about in class that multiplication is when you are joining equal sets, or in this case it could be grouping. Alright, and then when we are doing division, it is called separating equal sets. Okay, so one thing that you need to remember about multiplying is that order does not matter. And the reason order doesn't matter is because 4 times 2 is equivalent to 2 times 4. The last thing that we need to talk about with multiplication is that of in a word problem, as long as it is groups of something, means multiply. Now let's head on over to division. Division, separating equal sets, the one thing about division is that order does matter. So we're going to write that down here. Order does matter. And the reason order does matter is 4 divided by 2 is equal to 2. However, 2 divided by 4 is not equal to 2. It is equal to 5/10 or 1/2. Completely different. So it's something that you need to definitely pay attention to. Whenever we are doing division, you need to remember to set it up as the total, which is going to be your dividend, is divided by the parts. And that will give you your answer. So again, the total is the number, I'm going to abbreviate number with the pound sign, being divided, or in this case, separated. And of course, when you're using division, you need to remember to use your KFC. And we'll talk about that in a moment. Last but not least, we're going to talk about when multiplication and division problems have keywords that are the same. You'll notice the word each occur in multiplication and division problems. So you cannot decide whether it's multiplication and division based on the word each. Secondary, per. Per is another word that you will see in multiplication and division problems. You need to remember that you cannot rely on that word to tell you to multiply or divide. Let's move on to the middle. We're going to do two problems together. Let's take a look at A. 1/5 of today's college students began computers between ages of 5 and 8. If a college has 3,500 students, how many of the students began using computers between the ages of 5 and 8? Well, there is some extra information in there. The between ages of 5 and 8 really doesn't have much to do with the math problem itself. It just has to do with how they worded the problem. So we're going to go ahead and cross this part out. It's extra information. I'm going to read this again because it's important that we understand what the question is asking us to do. If a college has 3,500 students, how many of these students began using computers between the ages of 5 and 8? So we have 3,500. 1/5 of today's college students. So it wants 1/5 of 3,500. 1/5 of 3,500. Of in math tells us to multiply. So we are going to be doing a multiplication problem here. So I'm going to go ahead and write 1/5 times 3,500. And I'm going to write it as a fraction, that 3,500. And the way that we write that as a fraction is putting it over 1. When you multiply across, you get 3,500 in the numerator and 5 in the denominator, which is telling me essentially that I need to divide. So I'm going to come over here to my white space and I'm going to set up my division. 3,500 divided by 5. Let me move this over so you can see that. 5 goes into 3 0 times. 5 goes into 35 7 times. 7 times 5 is 35. Remainder 0. Bring down a 0. I'm not done dividing even though I have a remainder of 0. 5 goes into 0 0 times. 0 times 5 is 0. Remainder 0. Bring down the next 0. 5 goes into 0 0 times. Remainder 0. Now, have I used all the numbers in the dividend? Yes. Do I have a remainder of 0? Yes. Now my answer is done. 700 students is my answer for those that began using computers between the ages of 5 and 8. Let's head on to question B. Kyle is putting his video games on a shelf. The shelf is 12 inches long. If each game is 5/8 inches wide, how many games can he put side by side on the shelf? Now it's really important to me that you understand this problem and how it's being done. So I'm going to show a quick model. Here's my shelf. And it is 12 inches long. And I am having to put games on that shelf that are 5/8 inches or wide. So the problem is I need to figure out how many 5/8 can be made out of 12. Because of that situation, I am separating my 12 inches into 5/8 sets, or in this case 5/8 pieces. So because I'm separating a set equal, that means that we are doing division. Now remember, I have my whole divided by my parts. 12 divided by 5/8. Okay, well, I got to do KFC, but before I do that, I have to make sure I have a numerator and a denominator. 12 has to become 12 over 1 divided by 5/8. Now that I have my numerators and denominators, I'm going to do KFC. Keep the first fraction. Flip division to multiplication and take the reciprocal of 5/8, which is 8/5. Now I need to multiply across. 1 times 5 is 5, but 12 times 8, I'm not too sure if I know that one off the top of my head, so I'm going to come over here and use my scratch sheet of paper, and I'm going to multiply 12 times 8. 8 times 2 is 16, carry the 1. 8 times 1 is 8, plus 1 is 9, so it's 96. And from there, I have an improper fraction, so I need to change my improper fraction back to a mixed number. So I'm going to go ahead and set up my cowboy and horse. And remember, since my numerator is my cowboy and it's really big, I'm not going to be adding any or buying any donuts for sure. So here we go. 5 goes into 9 one time, remainder 4. Bring down the 6. 5 goes into 46. 9 times 5 is 45. Remainder 1. I am done dividing. Now I have to create my fraction. Well, my whole number is 19. W for whole. My remainder is 1, which is my numerator. And my denominator is 5, because it was already 5, so it's going to stay 5. So I look at it and I can get 19 1/5 games on my shelf. Now if I was thinking about that logically, can I get 1/5 of a game on a shelf? No, not going to happen. So therefore the answer is 19 games. For homework tonight, what I would like for you to do, and what you need to do, is answer questions C, D, E, and it says G, but let's go ahead and change that to F, on your own. You need to circle whether it's multiply or divide for each one, and you need to work the problem out. Thank you so much, and y'all have a great evening. Bye.